Hacking Hub is a new online cybersecurity training platform put together by Namsek or Ben Sadegapur, Build Hack Secure or Adam Langley, Todd Bailey, and me. If you scroll down to the very bottom, actually, hey, you could take a look at our leadership team, and there's my ugly mug there. Look, we are slowly but surely building out Hacking Hub, but there is one cool new thing that I'd really love to show you. So Ben and Adam put together some sweet new hubs to be able to learn SQL Injection, that structured query language for databases, and how you might be able to use and abuse it for offensive security or hacking work. And the best part is, it is totally free. So if you would like to follow along to learn some interactive SQL injection, there is a link in the video description, but you can just as easily go find this at hackinghub.io. So if you click this Start Hacking button, and we can roll through all three of these in this video. But I do want to note, hey, if you see up at the top here, all of this is part of Ben's Bug Bounty course. And if you'd like to dive into the whole thing, if you want to get all of the extra lessons, you can totally jump in to the full course here. Let me say that is fully Ben and Adam's course. All credit to them, that is totally their work, but it is so much more web security concepts and learning how you can hack web applications more than just SQL injection. Also dig into cross-site scripting, cross-site request forgery, server-side request forgery, remote code execution, so much more cool stuff. You can log in to actually make the purchase here. If you haven't created an account yet, you can simply register. But if you were to view this page as you are logged in, it will auto-populate with this sweet discount code SQL YouTube. Once you enter that, that'll bring it down to about 50% off. So that's a good thing to roll through if you're interested. Anyway, we can start to dive into these hubs and learn a little bit of interactive SQL injection. First things first, we want to understand SQL, that structured query language, and learn, hey, what it is, how to create your own queries, and select particular data and filter results from a database. So, hey, getting back to basics here, let me click on View Hub, and spinning this up, they actually have a whole video demonstration to walk through this just as well. Adam is showcasing it in a really good way, so if you prefer to listen to him, learn from him, maybe better than me, I'm sure he does a better job showcasing it than I do. Anyway, what we want to do is launch this hub and get it fired up. Eventually, we'll answer the question here. Look, what's the flag that we find after we know how to extract it from the flag table? So let me go ahead and click that button to launch the hub. And if you scroll to the very top, it'll go ahead and start to build out the domain, the scope for what we can start to hack against. Now we have this ready here, YUFWM, just a randomly generated domain. We could copy and paste that, or we could simply click open, this button here, and that'll bring us right to it. Ooh, this is pretty cool. Okay, so look, this is going to be interactive in how we learn how to use the structured query language, and especially how we do some SQL injection. And Adam Langley, Build Hack Secure, is the one that put this all together. I think it's pretty cool because you do get to see the SQL statement or the instructions that are sent to the server and actually ran against the database. So if we wanted to try this, we will select all the columns from the table named customers. Now you might be pretty familiar with the syntax. I like to enter the clause and instructions here in all caps so we know, hey, that's database or SQL instructions. Let me say I want to select as the keyword to pull down some data, and the asterisk can represent all the columns from a given table name. In this case, the table name is customers, so I'll enter customers here. It is probably a good call to end all of our statements with a semicolon, because that will note, hey, that's the very end of one instruction or some snippet of code we want to send to that database. I can go ahead and click query here, and that will say, these are the results. We see Adam, Bob, Brian, all in the first name column, and each of the rows here will be filled out with all the data in the other columns, like the ID number, their last name, email, etc. Now, if you didn't know that, if you were trying to learn a little bit and you want to just go see what the answer is, you can always click answer here. And they like to include this in lowercase, that works just fine, but ultimately we got the very same result. So now that next button has turned from red to green, and we can move onward across all of these little tasks at the top here and move on to lesson number 2. Now we can get specific as to what column we actually want to select. In this case, we want to select the ID and the first name columns from that very same table. So we'll use that same syntax, but rather than an asterisk or a star here as the wildcard to say, hey, give me everything, we want to specify ID, and then using a comma to denote a delimiter, separate these, and the first name columns. We saw those just as they were returned in that previous section. So now I can say, select ID and first name from customers. We spell that right, and let's get a semicolon on at the very end here. So fingers crossed, let's hit query, And okay, now we've got just those columns returned with all the data that's included in the database. Looking good. Just to check our work here, let me click answer. And yep, very same sort of structure, really just including some white space or using those lowercase, but that's fine. Let's continue onward with the next button. And now we have the where clause. This is pretty handy because we can filter or narrow down on what kind of data that we want. Like we saw 3 rows returned just previously, Adam, Bob, and Brian, but one of those had some specific properties, like the different fields or the columns that we might want to specify, like if their ID was just equal to the number 1. Let's say, okay, let's select the ID and first name from customers, and now we'll use the keyword and the clause where. I'll include that in all caps, and we can specify kind of a condition, like some logic here. I only want to see the results. Give me only the rows where that ID value is equal to the number 1. I'll include a semicolon here to close that out, just for some good practice, and I'll hit query. There we go. That succeeds. Green results here, ID 1, only giving us row for Adam. No Bob or Brian in this case. We can keep cruising, let's hit next. And now we can filter in a different way. Rather than using the equal sign, like to say statically, specifically, I only want something that is equal to the number 1 when we're looking at that ID field. Now we actually want to look at the first name column, and we want to see anything like Bob or Brian. But the key word there is like. Maybe something that starts with the letter B. So what we could do is, using the same sort of structure, select ID and first name, given those are the fields that we want within this structure of the syntax here, from customers, where, using that same clause keyword, that first name, we'll specify that as the field or column we want to zoom in on. Not using the equal sign here because that's a little too specific. We want to say that it's like a specific kind of string, because these are all plain text pieces of data, right? Like the word Bob or Brian is a string of letters. So we'll include that in 2 double quotes here. And we could actually specify, look, I want the letter B to denote, okay, the start of someone's name, Bob or Brian. But to use a wildcard here, like to filter out, okay, it could be anything. It could be Bob, Brian, Billy, Brandon, whatever. We won't use the asterisk, just like we had previously in the select statement. We'll actually use a special little operator when we're using the like keyword here. And that is the % sign. So fingers crossed, that will actually let this fill in Brandon or Brian or Billy or whatever. But B will be the anchor that will specify, I want everything that starts with B, including with that % sign to denote that. Let's hit query and see it in action. All right. We've got Bob and Brian, but Adam is nowhere to be found. Looking good. Okay, we're still cruising. Let me hit next here. And now we can have multiple where clauses. Ooh, okay, so we get a little bit of extra logic here. We add some other conditions with either some operators, logical operators, like and something else, or something else. In this case, it looks like we want the and keyword, and that works totally fine when we use the where keyword in our SQL syntax. So we'll build this out as usual. Let's select the ID and first name from customers, all in that usual structure, where the first name column starts with B is the criteria here. So we can use the very same sort of setup where it is like, double quotes for our string here, B, not using an asterisk for a wildcard, but using a % sign. And now we get to use some of the extra logic. We want to use and. You could just as easily use or here, but and is pretty good to say, look, I want to make sure both of these conditions are true. Both have to evaluate to true, or a 1 and like a 0 or 1, sort of like, logical AND gates or truth tables or the binary bits that you might tend to see in computer speak. I want to say and the ID is greater than, and we can use that alligator face, waka waka greater than to say greater than 2. Let me add my semicolon here, even though it's not really necessary. I think it's good practice just to keep it in there. So let's try to query this. And that's looking good. Okay, so in that case, we've got rid of Bob because they only had this ID field of 2, but we're specifying, look, it has to be greater than 2. Not greater than or equals. We could just slap an equal sign in there to specify greater than or equals to, make that inclusive, but we only want things greater than 2. So 3, and Brian, the first name returned. Sweet. Now this is pretty simple. Now we still want to be dumping data from the database, but we want it ordered and sorted in a specific way. These can either be ascending, like, hey, moving from up, or moving down in descending order. You'll see that in action as it comes through, because ultimately we want to select all the columns. What's that going to be? The asterisk and the star, right? Select all with our star asterisk wildcard there, from the table name customers, so we can keep building that out. But there's a new little clause here we can mix in, and it's genuinely called order by. Order by. Again, keeping that in all caps, just so we can kind of make sense of the instructions compared to the variables or things we might specify or change here. They aren't really variables, but they're things that we can tamper with or choose what we want to filter and select, right? So I could actually now specify what we want to order by. In this case, we want to order by the column name ID. So order by ID, but we want this in ascending order. So there's a little bit of a hint here in that title here. The shorthand sort of syntax and note for that is ASC. That will order it in ascending order. I don't know why I went down with that. Maybe descending is that direction. Up is ascending, right? Let's see it in action. I always get my up and downs incorrect here, but that should work. It's growing in number, 1 and then 2 and then 3, returning all this as it should. But in the next section, let's actually order by descending. And you'll see the difference here. This is really the syntax and structure that you need though. Super simple, super easy. I know it looks like English language almost, but order by ID, column that we want. And I'll hit next, and let's see that in descending order. Same exact setup, ID, first name. Actually, no, I'm sorry. We want the asterisk here to select all the columns, don't forget. From customers, order by ID, DESC. That is how we can specify descending. Let's roll through that, hit query. Oh, I had a typo. Hey, there we go. Now we got our first couple errors here. SQL results, you can see how this is in red, how the system is telling you, oh, that was bad, and it'll include, you have an error here. Looks like you do have a mistake. Check the syntax right beside your by ID DESC, because I wrote ordery by. Haha, I'm silly. Every single mistake could mean an error. Let's hit query, and now we're looking good. Descending numbers, right? So starting at the top value 3, going down 3, 2, 1. We're almost done with this first hub here, so let's hit next and keep going. Oh, and this is another simple one. Now we want to limit. We only say, hey, I want to select just about everything, select all, but I only want one result. Limit to just the first row, and super simple, looks a lot like order by in the order and sort of, hey, chronological depiction of what comes when and where in our syntax. When I select all from customers, previously where we had order by, just following that select from syntax, now we'll actually specify limit. And limit gives us, hey, how much we want to limit the results by, right? So if I only want one result back, we'll just enter 1. That should be the very first row, correct? Slap in that semicolon. With that syntax and structure staged, let's hit query, and that's all green, looking good. Now we've just got Adam ID1 coming back. Next. Now we can limit skip. Let's select all the columns from table name customers, but limit the results to just the second row. Ooh, okay. So this is a little bit of a fun one because it's not exactly what you think. I know maybe someone might say, okay, let me select all from customers, limit maybe 1 and like skip 1 or like offset 1 or whatever. But actually limit is a little bit special. When we used this keyword previously, we could actually specify with a comma, kind of like what we were doing previously to specify ID and first name here, just using a comma to separate more things we want to include or specify. Look, you could specify more of how you want to limit things. I want to skip however many values, like 10 or 20 or 30, and only get the first value following that. But in this case, if we just want the second row, our offset, or how much we should skip by, that second sort of argument or parameter there, right, should be just the number 1, right? Skip the first one, return the next one following it, limiting only one result returning to us. That's going to be the second row. Let's include the semicolon, slap that in, hit query, and we're looking good. green to give us some good answers. ID 2 here. All right, we're just about to wrap up this whole introductory understanding SQL here, but this is where we can start to fall down the rabbit hole, because the union statement gives us a little bit of superpower when we start to do SQL injection. When we actually start to weaponize this for potential payloads or some exploits we could fire off at a website, union will help us extract more information from the database. And I'll tell you about that in the next hub, but take a look. Select the email columns from the customer and suppliers table. Ooh, okay. So normally we'd be thinking, let's select the column name email from customers. And we saw that field or that column previously in all of our results, right? But that would only return things from the customers table. So could we tack on something else? Could we actually put this together and join in a certain way? Not strictly join for folks that are familiar with SQL, but actually putting together the results from two different tables. Could I continue to select something else? Well, yes, you can with the union statement. And we could actually use another union select where we could specify, look, I also want to get the email from a totally different table, in this case, suppliers. Not a whole lot of extra logic there. No fancy tricks, nothing up our sleeve. That's all that it is. We're just putting these two select statements together with union. Add a semicolon in there. Let's hit query. Let's see it in action. And there we go. We've only returned the email column, but now these entries will be returned as both the emails that are included in the customers table, as well as the ones from the suppliers table. That are these two that we haven't seen before, right? Acme at fakemail.ctf and widgets. Those are still being tacked on or added to all the results that we got back because we did a union select to put them all together. Looking good. With that, I think we can wrap it up, right? Now we just need to know what that flag is. So we have a lot of capability here, though. We've built out, look, how we could actually query anything we want from the database. And the database is going to be its own structure, right? We know we've been usually working in this customers table, and that has these different columns and fields and rows here. But when we saw the question down below actually asking us, what is the value of the flag in the flag table? Okay, that clues us in. There's clearly a table named flag, and there's likely going to be a column or a field or value that we could pull out called flag, right? So what's the syntax that we should use there? Let me hop back over to our little playground and let's try to select flag, right, from flag. Close our semicolon and let's hit query. Invalid dataset was returned. Okay. Oh, okay. But it gave us the flag. Neat. Maybe a little bit of hacking right then and there because look, we got that strange error, maybe something the app wasn't expecting, but we did get the data that we wanted to because we could directly enter whatever SQL statement and query that we wanted. Usually when you're working with an application, you don't have all that flexibility. You're going to have to work with whatever the statement or query is already built out to be, and then you'll just have sort of an injection point. So maybe rather selecting from one specific table or selecting whatever column, or in just like a where query, the ID is equal to 1 or integer 2, 3, whatever, you'll have to do something special just in that little placeholder. We'll see that in action in the next spot, but let's go ahead and submit this flag and say, hey, we've completed this hub and learned a little bit about SQL. Let me hit answer here, and then we're good. We're done. We've completed that task. Uh-oh, give you a little celebration up top. Yeah, challenge complete. Congrats on finding all the flags for understanding SQL. Good luck on the next one. Oh, I gotta tweet my success. Would Ben and Adam laugh at me? Would everyone else laugh at me? Now we can check that one off our list, the big check mark there, and let's move on to that union-based SQL injection. This is where we get to some of our actual hacking, right? I know I was doing some intro stuff, hey, trying to show you the language, structured query language, and SQL early on in that first section, but now we're going to dig into union SQL injection. Same exact prompt, hey, what's the value of the flag in the flag table? But now if I launch Hub, scroll up back up to the top here, we'll see this actually spin up its instance. Super quick, by the way. It's like lightning fast to get this thing ready. There we go. We can copy that or open it, and here we are. Article 1. This is the public article. We can click to read more, but also at the very top, you might be able to see we have a SQL injection helper here. Okay. Well, let me try to read more, but that's about it. Okay. So I'll go back in my browser here, and I do want to dig into this SQL injection helper. Ooh, now this is again pretty cool because it'll show you, look, everything that your URL is, and this is just included as like a get parameter when you're accessing the website. But if I were to hit go over here, you might be able to just see, and I know my face is in the way, it'll return, look, this is the public article. We could see it ran select all, select that star from articles being the table name, where, and filtering, column here released is equal to 1 and ID is equal to 1. Given as a string. Interesting. We get that result back. So what's to stop me from just showing ID 2 in this case? Try and show article ID 2 by changing the logic of the query. Okay, so we'll hit go, but no data was returned. Oh, probably because we select all from articles where released is equal to 1 and ID is equal to 2. But released might not be 1 for that article ID 2, right? That might not be true in this case. So we'll have to kind of futz with that. So that's probably why it's not returning. What could we do here? Well, let's do some SQL injection where we know our placeholder, like the underscores that I was referencing earlier, that's exactly that spot where we can inject into the query or the statement. So I want to change this now to even kind of like break out of the single quotes here, because you see anything I type in here is going to be wrapped in these single quotes. So if it's not protecting or validating our input, if there's nothing to kind of sanitize, hey, if we were to enter any special characters, unique stuff that could ultimately trick the backend server and the database to say, look, what I'm providing as data, I actually want to end up maybe tweaking a little bit and putting code, like SQL syntax. That's exactly what we do if I were to enter a double quote of my own, or a single quote in this case, right? Because that would sort of break or interrupt anything else. It's as if this ID equals an empty string denoted by these two single quotes. So anything following could be more SQL statements, right? Like I could do an and or an or another union select, and we'll do that very, very soon. What we might be able to do here, if ID returns empty string, and that's the filter that we're looking for, we could even make that like a 0 or whatever, anything that doesn't exist, doesn't matter here. If we use that or logic, one of these has to return true, just one, using that or logical operator. So let me say, give me an article where release equals 1 and ID equals whatever, or ID equals 2. But you might see that we're doing weird stuff here because we have a dangling or leftover single quote. Now the server is going to break an error on that, right? Like if I actually try to hit go on this, SQL results, you have an error in your syntax. Please take a look at our dangling random weird single quote. So we need to actually end that. But we can't put it at the end here because then we just have, again, some naked, bare, open, randomly floating string of single quotes. But what if we matched up with the other actually included single quote and we just put one right before our number 2? So then it properly reads, okay, ID can be empty or ID can be 2, the single string, with those two quotes surrounding it. Let's try and hit go on that. Oh, and we got it. This is the unreleased article being article 2, and it's returned ID 2. See, released was 0 all along when we get this result back from the table. And this is data that you won't normally see, right? Just like we saw from the actual web page, that only returned this information. We don't get to see the behind the scenes info, usually, especially even the query that it runs. Unless there are any mistakes, any mishaps, any accidental developer oopsies, this is normally information that you don't know. So you have to get a little bit clever with how you start to do your SQL injection and enumerate things. But thankfully, our union select statement might help us enumerate pretty easily. And that's exactly what we'll dig into now. Use the union command to work out how many rows should be returned. Okay. Why would that work? Well, how would that union statement do that for us? Well, if ID article 1 will return just fine, actually giving us an article, but we want to use this now to get an idea of how many columns are returned. Well, we can see, given this sandbox, playground, exploratory education sense, there are 4 columns returned. But if you didn't know this, if you put your blinders on and were to say, hey, okay, I need to try and figure out how many columns there are, the union statement can do something really interesting. Because let me say, let's close out the string here, again, providing our single quote. And if I were to try to use union select one more time, we could select anything. Like, I don't know, that would be a string, right? So we wrap that in single quotes or double quotes. But if we were to select like the number 1, normally you might think, okay, we need to select from a table, like customers or whatever. You don't actually have to do that. If you're selecting a literal, like just the value 1 or that string anything, you don't need to say from a specific table. So let's select 1, and now we've got a problem though, because we can't as easily maybe close out our string here. Well, we could, right? We could just wrap this with another single quote here, but what we might also be able to do is actually include a comment. Like, hey, comment out, like don't even interpret or don't listen to the rest of the statement or the query there. The syntax to do that in MySQL is typically, I've seen the hashtag or the octothorpe, scientific word for that. Or you could also just as easily use 2 hyphens, 2 dashes, 2 tacks, and that will typically comment it out. I'm used to seeing that more often in SQLite. Apparently it works just fine in MySQL, so I learned that too just as well. But if I were to run this, see, we're breaking out of our original string, using a union select and commenting out the rest of the query. So whatever follows this is not ran. I can literally leave that in because the comment's not going to care. I'll hit go here, but we get an error. The use select statements have a different number of columns. Special, interesting gimmick with the union keyword, in that if you're putting that together with another select previously, you have to match the number of columns. And we didn't see that issue when we played with this in the previous hub, but in this case, it's super duper important and actually helps figure out, okay, what is the structure of the table that we might not be able to see or know about behind the scenes? That's all server side, right? So let's change that to 2. I'll go ahead and hit query on that. Same exact error. I'll go ahead and hit 3. Same exact error. And we would go through that process maybe manually or in an automated way to be able to track down the correct number of columns in a select statement. You'll know that you got the right number when it actually gives you data, and you'll even be able to see your results come back. Like me, union select 1, 2, 3, 4 with our comment at the end here, and we can remove that little bogus stuff. Let's go ahead and enter this, and you'll see it returned. Ooh. We got the same row that we usually get, but it even returned tacking on the select statement that we would have done previously, right? 1, 2, 3, 4, with everything we specified to select or pull down, even as a literal here. I'm curious why this is still angry at me. I think, and I have a hunch, if I actually hit the answer button to see what they were looking for. Okay. They probably had a 0 here and then it used a semicolon to denote the end of it for a statement and a query that we could end up running. That's okay. We'll hit go. That should give me green results here. And now that's going to return just our union select working as it should, given the rows and pulling that data down, determining the correct number of columns. In this case, 4. So let's hit next and keep cruising. Using the previous command, swap column 4 to the word hello, and then show that characters can also be returned. Ooh, okay, so this is exactly what I was alluding to earlier, right? When I kept throwing just that keyword anything around wrapped in a single quote, that's a string, right? So we could just as easily return characters, could we not? Let's break out of the single quote. Let's do our union select syntax, injecting some SQL statements into the query that is already built out server side. And let's select 1, 2, 3, 4, as we know that's the correct number of columns. But rather than that value 4 here, it just wants the word hello. So that should be wrapped in strings, right? That needs to be wrapped in the single quotes or double quotes, because otherwise it's not going to know what the heck that means, as if it were treated as a command or an expression. If I go here, says unknown column hello in field list. Okay, it's going to treat it as a column, right? Because that's what it's trying to select. Let's wrap that in single quotes or double quotes, just as it should be as a string. Let's hit go. And now we get the result we were looking for. 1, 2, 3, and then hello down here. But again, I'm probably not getting something right. What does it need here? Let's hit answer. Needs to be a 0, and then close out some of that white space. Okay, same syntax, same structure. Let's hit go there. We get our green results. Sweet. So let's keep cruising. Let me hit next. And now we can start to even extract the current database name. Ooh, okay. So look, this is because we can use some special functions within SQL and actually try to figure out, it'll even just return with these 2 parentheses wrapping this around, like, hey, trying to call a little procedure and return what is the name of the current database that we are in. So let's use that built-in function in the place of our, I don't know, for column. Let's use our union select 1, 2, 3, and then rather than for and rather than hello, we'll put in place here the call to database with those 2 parentheses to denote we'll actually want to call that. Let's close that out with our semicolon, add our comment with the 2 hyphens, dashes, or tacks, and let me hit go. Ooh, looking good. SQL results already back in action, and you can see all the results we would expect, including now data returned from the return value of this function, figuring out what the database name is. In this case, SQL I2. All right, let's hit next. Now we're really starting to build out our superpowers here. We can do some pretty functional explicit SQL injection. And that's what that's called, right? When you're getting the results even returned back out to you, what you're trying to query or you pull down, when you have it dump or select from a database, when you can control what that is and it's displayed to you in the results and whatever API or web page responds with, then you can see it and it's explicit. So let's try to now use some special stuff. Let's try to use another unique and interesting database that's actually included within MySQL by default. There's this special thing called the information schema database, and we could use that to extract some structural information. This is all possible, by the way, because the information schema database holds some special information about the structure of the entire database, the entire MySQL instance that's running, the server behind the structured query language here, the database management system, right? We could actually be able to track down the other tables present in this whole website's backend, all the other databases and all the columns, all the rows, all the data, we could track it down with the information schema database. So what we'll do first is try to track down the other database names. Like we saw SQL I2 previously, but there must be a maybe SQL I1 or SQL I3. So what we could do is use the schemata table and try to track down the schema name column. But because there are lots of results and rows and things that are returned from that, it's kind of hard to have that all packed in and included in just what would be one field in a union select spot. Like we can only inject into and see our results back in that column 4, right? When we were messing with the word hello and we saw the database return, that's only in one little pocket, not a whole row or a whole column. So what we could do is use this special keyword group concat. And that's a function, really. We'll see it in action here because we'll specify, look, I want to union select 1, 2, 3, 4, again, to match the number of rows, but replacing this 4 value with something special. Let's select, and I'll use parentheses here to denote a subquery, like another piece of SQL and instructions actually included within one other statement or query itself. So that's a subquery in these parentheses. Let me select group concat. That's to concatenate or put together all of the column results coming back from one specific column that we specify, in this case, schema name. And I note, the go button is kind of in the way, so I'm going to add a lot of spaces here at the end, just add a little bit of white space padding. But selecting the schema name, given that column that we're looking for, from information schema, being the database that I want to mess with. And remember, that is a database that we're trying to pull from, but usually the from keyword only expects a table. So what we can do if we want to specify another database bucket to pull things from, let's actually include the name and then a period, or a dot to specify the table inside of that. So we want to get the schemata table. Goodness gracious, I can type. And now we've just about got the syntax ready for us, right? What we're doing is we're union selecting 1, 2, 3, 4 to fill the columns, but as our for field, we're actually going to do a subquery within these parentheses to select all of these schema names, like databases themselves, concatenated together so they fit into one little resultant field here from that special database information schema and the schemata table. Let's go ahead and click go here. And now if I scroll down, ooh, okay, this dumps all of the database names, including information schema itself, another one called performance schema, and SQL 2. Okay, so there weren't any SQL 1 or SQL 3 in this case, but that's okay. Now we've at least proven this concept, and this is how we could actually build out and extract whatever we want from that information schema database. And this is how we could determine all the other information about different parts of the database, like all the other tables, all the other columns, and whatever data that we want. With this SQL injection capability and the explicit results returned back to us, we could literally dump the entire database. So let's go ahead and click next here and see what we'll do now. Now that we know the names of the database, we can extract a list of all the tables from information.tables using the table name column. Ooh, okay. So we'll do the same sort of setup, right? We'll do a 0, whatever, doesn't matter what field here. Let's union select, match the same number of columns. For our fourth field, though, let's do a select group concat, and this is the usual syntax that you'll get used to for trying to pull all the data in one, kind of funneled into one spot here. Let's get the table name column. And let me pad this with our semicolon and then comment to note the end with a bunch of spaces to add some white space so you can see it. We want to pull that all from the information schema dot tables table. I know it's very funny, right? The tables table. But that's really what it is. If I click go here, oh goodness, there's a lot. Administratable role, applications, roles, character set, check, constraints, collations, character set, okay. All of these are the usual built-in, included, and just part of MySQL in the database here for all the other stuff that it might do. I want to double check here, and this is kind of the fun, hey, all the part of our learning here. Is this exactly what it was looking for? Let me click answer and see what they're up to. Ooh, okay, they want to track this down for the specific table schema, referring to the database here, right? We know the database name was SQL 2. So if we were to adjust our query here, remember that where statement or that clause? When we do that from, just as we did previously to specify the database.table, we want to specify where this column is specified as SQL 2. That means we're only going to get all the tables present in that database. And that's the database we knew that we were working in, right? When we ran that database parentheses function. So this would help us enumerate and track down all the other tables that we're interested in, like articles, flag, nice, and the users. Okay, cool. So we had the right little concept here. We had the right syntax, but we hadn't quite drilled down into that specific database. But it's good to be able to do that, and it's good to know the table schema is how you could determine, look, that is the database that we want to work with, knowing the one that we're inside of right now for our app. Cool. Let's keep cruising. Hit next here. The last step of understanding the database structure is to find all the column names and table users, and we can do this from the information schema columns table, extracting the column name column. Oh boy. Okay, this is when it starts to get a little bit complex, and we'll build this out, right? Let's do our union select, and I keep changing this to a 0 just because I think that's the answer that it's looking for. So I'm trying to get it right, but I'm probably going to get it wrong anyways. But that doesn't matter, remember? That's all just going to be dummy data inside of this string of single quotes that we're ignoring anyway, because our union select is where the real magic happens. So let's get the same number of columns as usual, but let's use a subquery with parentheses as usual. Let's group concat to pull down and mix all the data returned as usual with the column name, and I'll add some spaces in the mix, from information schema.columns, where And I'm assuming we're going to want to filter here, which is why I'm tacking in that where clause, where the table name, is that the right field name inside of the information schema? Let's find out. If that's equal to users, right? That is what we pulled earlier. Table name is the column that we tried to pull with our group concat in the previous lesson. So table name being users here, I think we've got everything right. Let's try it out. Let me hit go. Ooh, green results, looking good. All right, so now we've been able to determine not just the databases, not just the tables, but even the columns inside of those tables. So next, all we need to do is dump all the data. And we can do that now that we've got all the field information. Let's kind of keep cruising and see if we can concatenate and dump out all of the username and passwords inside of this database and do all this SQL injection. Really weaponize it, put it to life here. Now we know the whole structure, we can query the users table to extract the username and password columns for just one user. Okay. So could I get special, break out of our single quote string there, union select, and this could be 1, 2, 3, and now our fourth column, again, where we're putting the data here that we want. We could probably do a query, or actually, honestly, we could select like from the users table since we know that that exists. We might not even need our subquery, and maybe we could use more than just the fourth column here. Like we could straight up return the username as our third result and the password as the fourth result, right? I think that would work. It should just dump those fields from specifying a table this time that's in the same database. Let me hit go. I don't know if it worked. Oh, it dumped a lot of them. Okay. Maybe we could limit one, right? It only wanted one user. So let me do a limit one. It did give me a red result, and that was probably wrong, but I dumped everything. So let's try to do that with limit one. No, that was wrong. Didn't seem to get anything back for me. Okay, what is the answer? What am I looking for? Wait, what? You just needed the 0? Did I have that wrong? Okay. Let me hit go. It still gets it all just fine. It still works. Maybe the 0 was the issue, and I just maybe a little bit sensitive and finicky on what you provide for the fake bogus data. But there, we're dumping admin, password 1, Adam, password 2, Ben, password. Look, you couldn't have given me a better password. I couldn't have been a little bit more secure. I'm supposed to, have some credibility in this crap. I don't know. I try anyway. And now we are finally just at the end. Let's extract all user data in just one query to get in one row or one field, one piece of data, all of the users. We could group concat all the results and even concatenate the username and password together. So this is a little bit sweet. Let me do 0 as they've been doing previously. Let me union select 1, 2, 3, and our fourth to match the columns. Let's do our subquery this time for real. Let's try the subquery and then see the answer of what they were looking for. But let's group concat, and we can actually, inside of that, concatenate with just this other sweet function here that MySQL gives us. And I'll comment this out here and add some white space. But concat with 2 parentheses will actually just regularly concatenate strings. So we could put these together if we say, look, I want the username, and I want to match that with a colon to denote, hey, a username and a password that might follow. And I want to see if I can do that, pulling that all from our users field. Is that going to work for me? Am I pulling that out of the hat and wrong? Nope, I got it right. Okay. Sweet. So now we pulled colon, username, colon, password, username, colon, password, and we've got everyone's credentials all in one query and all in one row, all in one result. So that's even better and makes our payload, our SQL injection here, a little bit sharper. So I dig that. I like that a lot. And with that, we have dumped all the credentials in this database, and we have finished all of the little lessons here for what we might do for this hub. But we still have one other objective, right? If we go way back, we still kind of want to know what the value of the flag is in the flag table. Okay, so what's everything that we've learned here? We can kind of, start from a clean slate, but our query, the SQL statement that's being ran in the back end, we only still have this injection point here. We don't have control over the entire SQL statement. But we know thanks to our union capability for this explicit SQL injection, we could just as easily union select 1, 2, 3, 4, because it has to have the same number of columns. We've learned that and seen that all throughout. But rather than 4, let's try to get the actual value, like the flag, from the flag table. Let's comment out semicolons to note the end and 2 hyphens dashes tax to be able to remove the rest of the SQL statement, that trailing single quote. So once I hit go, we should see the flag. And there it is. Excellent. Let's go ahead and submit that and call that one done as we bring it all the way back here. And my goodness, this video has gotten pretty long, I think, all the way at the end. But look, we're done. We did it. We did number 2, the second hub here. Congratulations on finding all the flags for union-based SQL injection. Good luck on the next one. And with that, we could go back to the next one. Let me hop over there to that interactive SQL injection. But I gotta say, I think this video is already long enough. So look, I don't think we'll cover this last final Boolean-based SQL injection here. I will show it to you super quick though. We can spin it up, and of course you can watch the other videos that we're all putting together. And I hope you do go play with this on your own. That is really the intent here. Look, I'd love to help be a springboard for you and actually get you into action to go play with Hacking Hub. Hey, try some of these, test them out, see if you're having some fun, take a look at some of the others. Zooming in on hub number 3, now we could try to create an account and then go see where our SQL injection might lead us to this time. In this case, looks like we have a SQL injection helper, but if I were to enter just like John, oh, interesting. It's testing whether or not the username is available or not. And do we have Adam available? Oh, no, username already taken. Okay, so here we have like a threshold or a Boolean, yes or no, 0 or 1, and that's all that comes back from the database in this case. We might be able to actually test if we could get a true or false returned if there are results as to whether or not a username is taken or not taken. In which case, we don't see the backend results from the database. We don't get the SQL results. We aren't sure of the query in the real-world testing app perspective. But with this playground, with this helper, you can learn a little bit more about how you could take advantage of that and do what a lot of folks call blind SQL injection. If the last one was explicit with union SQL injection, now we're doing blind SQL injection. And look, I will leave that as an exercise for the reader. I think this video has been long enough, but I did want to showcase, sing the praises, and hopefully introduce you to a couple of those tasks and challenges and activities from Hacking Hub. Look, by the way, actually, if you would like an even more, hardcore, crazy, big in the weeds web application security testing gauntlet, if you take another look back on the hubs at app.hackinghub.io, one of these is actually mine that I created. A lot of these are Ben and his incredible work alongside Adam and all the folks doing sweet stuff. But Bookstore is one that I had put together, and I am quite pleased with it. I don't know if I skipped it here. Let me keep cruising. Oh, I did. It's totally right on the front page. Bookstore. Take on John Hammond's Bookstore Web Application Security Gauntlet. That covers just about everything from SQL injection to local file inclusion to external XML entities attacks to cross-site scripting and a lot of sweet fun stuff. I would love to see if you could try your hand at Bookstore. But look, I hope you have some fun with it. I hope you dig in. Please do take a look. Link in the video description. Take a look at Ben's course and all the sweet stuff. Just wanted to leave this here as a resource for you. Please do all those YouTube algorithm things, like, comment, subscribe, and I'll see you in the next video.